Welcome back. So last time we looked at rendering some basic shapes and text and everything. We're going to look at in this kind of video we're going to be looking at image loading, which is a bit more interesting because you can be loading your own images. We'll see how images work and everything like that. So I'm actually pretty lucky because I recently got some better internet, so I can actually upload these videos pretty fast. So I'll do a couple more today, till about like 4, because why not? So we're going to be rendering a basic image. Do I have paint.net? I don't. So let me download that quick because that would help me out quite a lot. But basically, rendering images is really easy, like stupidly easy. And again, you have to remember the same optimization of only only loading the image once, because if you load the image 60 times a second or 1,000 times a second, it's really bad in your performance. Now, this is really annoying because it's not downloading. Where's the download? I hate this because they changed it, like the way that you download it, so it's really confusing. Okay, so let me explain. Now the first thing we're going to do is we're going to see how many times this update and render functions are being called. So we're going to make something called a timer, which is recorded in current milliseconds, and we're basically going to say if the system's current timer minus the timer from when we first started. So this basically stores the time in milliseconds from when we first started, and we're saying if the current time minus the timer is greater than 1,000, which is 1 second, or 1,000 milliseconds, this means a second has passed. And then we're going to add 1,000 to this second, just to keep it up to date with our current timer. So you'll see that it prints out once every second. So what we can actually do is we can say int frames equals 0, or we can say int FPS equals 0, UPS equals 0, and then we say every time we call the update method we increment the UPS, every time we call the render method we increment the FPS. Then we can print out the FPS into our console like this, and we can reset the timers. And we can see that it's being called about 60 times a second, and the reason why is because we added this. Now this 16 millisecond sleep, you may not think it was important, and you may have thought it was an arbitrary number, but it actually wasn't. And I know that when you set this to sleep for 16 milliseconds, it's approximately about 60 FPS. I think 8 is 30, I think, I could be wrong. Oh, it's more, sorry, no. 24 is 30, I can't remember, something like that. Yeah, about 40-ish, yeah, but you get the idea. So if I remove this, we see how many times it's being called now. 1,600, 3,000, 4,000, 5,000, 5,000. So that's a lot of... Ah! Whoa! Excuse me, I've been sneezing a lot. I probably have like hay fever or something, because, yeah, cut grass. Anyway, as I was saying, that's a lot of time, that's like quite a lot. 5,000, basically, these two functions are being called 5,000 times every second, which is an insane amount of times. So this little sleep that we do does make a difference, and there's a better way to handle it, which we'll do in a later episode, because it's not too important at the moment. This will do at the moment. This current method is not as good. Sleep is pretty bad to use, actually, but it will do for now. Okay, so let's go. Let's do this. So now we're going to do image loading. So I think my paint.net thing has installed. See how that's doing. Cool. And then we're just going to drag this out. Got to install it. I probably should have done this before I made the episode, but you know. Come on. Okay. Paint.net. Oop. Express, whatever. Yeah. I think someone cut the grass or something, because now I don't even know if I have hay fever, but my nose hurts. Okay, rendering images. I could have just downloaded an image off the internet. I probably should have done that anyway. Okay, so let's just set up for rendering images. So to render an image, we need something called, you guessed it, an image. So Java does a lot of this for us, so we just say image. And this is going to be the image we're going to render. So we need to import that with Control-Shift-O. And we only need to load it once. If you load it again 5,000 times a second, that's really bad, like performance-wise. So you want to load it in the initialization method. Now, we're going to need to set up a resources folder. Now, when I first started programming, I initially was like, hey, let's just load it from C users, Felix, my pictures, dog.png or something. And that's really bad, because if you distribute your game, no one's going to have, one, their computer isn't going to be C users Felix, two, they're probably not going to have dog.ping in their my pictures, maybe they will, and three, they might not even be on Windows, so theirs could be like /home/ Bob Linux PC thing /pictures /dog.ping or whatever. So you want to make sure that you have the resources in a folder. So we're going to we're going to embed the resources into the actual kind of jar file. So when you distribute your game, the resources will be inside of the executable, which is pretty useful. So to do this, we're going to make a new folder called res, or assets, whatever. I prefer res because it just stands for resources. We're going to right click our properties for the project. This is where it's kind of, it would have been better if you used Eclipse. I'm assuming that if you're using IntelliJ or NetBeans, you probably know how to do this. If you're using Eclipse, then that's pretty good. If you aren't using Eclipse, you might want to Google how to add the folder to your class path or something. So what I've done is I just click to this Java build path, you go to the libraries tab, add a class folder, and choose res, and press OK and OK, and it should get this little symbol in the bottom left. Okay, so if I run paint.net, which is perfectly timed, I'm going to just make a 64 by 64 image, actually 128 by 128. I'm just going to draw a smiley face and save it on the desktop. I don't know where this saves. Documents? Where does it go? Desktop. Documents. Oh, it goes in C users. Felix. Workspace. Oh, not. I don't know where it's saved. Okay, I'm just going to save it to the desktop and I'll drag it in. So I'll call this smiley. And we'll just press OK. Let it save, and then we drag this into the res folder. And make sure you copy the files, don't link them. We've got to copy them. If it doesn't show it up, you press F5 and it refreshes. You can also click it here and it'll refresh the entire project. And then we should have smiley.ping in our resource folder. And this also makes a difference because another thing that you need to think about is your operating system. So jar works on Linux, and it works on Mac, and it works on Windows. Now, Linux computers are annoying because everything is case sensitive. So if your folder is capital F and then Felix, then you're going to have to do the case as well. So say if you wanted to, I don't know, cd into that directory, if you do Felix with lowercase f, then it won't work. If you do uppercase f, then it will work. So when you're actually referencing this file, if I made this capital S, I should reference it like smiley.ping. If I don't, then it won't work on Linux, but it will work on Windows because they're not a pain in the ass. So I'm just going to, just to generally future-proof it, I would just do it all in lowercase. So just keep that consistent and no spaces, do underscores. Because with Linux you also have to do backslashes for spaces, which is a pain in the ass. So trust me, just do underscores and lowercase and you should be fine. Okay, so back to loading our image. So we're going to go in the init method, and we're just going to say image equals image.io. Make sure you copy that case. Read get class, which is a getter for this class. Get resource as stream, which shows up here. And then we just put quotes in, and we put a semicolon on the end. Now you see we get this error. This is because this could go wrong. So this read method basically throws an IO exception. This is what it will look like. So what we need to do is we need to say surround with try catch, and then we can remove this. Actually, I keep it. And I changed the E1 to EX because I just like it being like that. But basically, this means that if this fails to load the image because it could not exist or something goes wrong, then it will print it out the error message. And then for the get resources stream, we do slash. This is really important, and we do smiley.ping. If you have a folder in this res folder called I don't know, sound, you do /sound/. It has to begin with a slash. So if I do smiley.ping, it will give me an error. as you can see. If I do a backslash, it shouldn't give me a single error, like so. Now what we can do is we can then say in our g.draw thing, remember the g.draw image, we do g.draw image, the name of our image, which is image, where we want to render it, so 1990, and then null. And this is an image observer, which we don't need to worry about at the moment, so just keep it as null. And if we run this, it should render our image, which is great. And then we can also scale our image, so we can say, let's scale it up to 256 by 256, and this will make it twice as big. Or we can scale it down, so this is the width and height, remember? So 64 by 64, and it's a little bit smaller, sorry. There you go, that is how you render images, nice and easy. So we should pretty much have all the required tools for making a game. You know how to render graphics, you know about the basic kind of rendering system, you know how to do the colors work, and you know how the pictures work. And there's also a thing you can do, I never remember it, so I'm going to Google it, but it's called anti-aliasing. So if you just Google anti-aliasing with graphics 2D, and if I run this quick, you'll see the B thing. These circles are a bit jaggedy, so we can fix this by using the anti-aliasing, which is really easy. There. So you see this guy mentions it, how to draw a decent looking circle, and then we just need to copy this. I never remembered it. So what you do is go on Linux. Oh, is that 11 years old? Oh wow. Okay. Anyway, so just before we do our rendering, so I'm going to close this. We do G dot, and then we paste this in, and we'll get an error. And yeah, this is static, so I need to do this. I think it's static. What? Graphics dot anti. Oh, it didn't work. Okay, doesn't look like it wants to work. Oh, this guy even says the constants have been moved from graphics 2D, so we just got to change this quick. So I've never remembered it personally, so I always end up googling, so I just change this to rendering hint. Like this, and then that should work. Value, and I even changed the name. Key anti-aliasing, yeah, I'll do. Now you see this gets an error, and this is because it needs to be graphics 2D. Like this, except that won't work, so what we actually do is we can just say G, set rendering hints, and we change this to graphics 2D. And then when we set the buffer, we just cast this as graphics 2D. And then that still doesn't work. Set rendering hint. This is from like a probably 1.6, I don't know. So yeah. Then we run this, and you see it's a lot smoother. So yeah. Basically, Google is your friend. So if you ever start with a problem, just Google it. So we did a little bit of a change there. So we just changed it to graphics 2D, which is the newer kind of graphics API. And it gives you a few more things, but we don't really want to use any of them because they're not very good. In fact, most likely you'll probably only ever use the draw image. All the other stuff, I wouldn't recommend using it. Just use draw image. Okay, so we have our images. Now this is the beauty of programming. We can draw something simple like a tile map. So let's just say we want to draw, if you know like Pokemon, it's basically based on a tile map, so we do x times the width, so 64, y times 64, and boom, we have ourselves a tile map. So that's kind of the basic concept of how the rendering works. Now we just need to think of what kind of game we're going to make. So we could do something simple like Space Invaders, or we could do something a bit less simple like, I don't know, an RPG game, or we can do a top-down game, I don't know, a platformer. Platformers are pretty easy. I have no idea, but that's pretty much how you do the rendering. Next episode we'll be looking at the kind of actually doing the FPS properly, so we're not kind of hacking it in with the thread.sleep. Eventually I'll also look at some more advanced things, like a state system for changing states. This is only in one class as well, which isn't really very good. But this is kind of the back end for our game, and the rest is going to be pretty easy to do. That's about it. So thanks for watching. I'll see you next time.